Stats, A-level Specimen Paper 2, question 8, which I thought I'd already done, but I've got to do again. So we'll have a look. So, reading the question, Richard retired a few years ago and bought a small farm. On his farm he has 3 fields that each contain a similar number of apple trees. Pause the video, read the question. Basically, he has a load of apple trees and a load of farms, or 3 fields, and he wants to know if there is any correlation or association between where he gets the good or excellent fields of apples and where he gets the not so good. So basically he's got the top field and all this, where he gets 36 excellent, 36 good and 21 satisfactory. So there's a lot of information there, and he wants to, where is it? He wants to write any necessary assumptions and carry out a test to see if there is any evidence to support Richard's suspicion, the 5% significance level, and he suspected that there may be an association between the quality of fields. The word we're looking for there that stands out is an association. So this is the hypothesis test where you've got H0. Oh, if I can get my points. There is no association between, this is the one everyone hates writing out. We're going to go with apple quality and field grown, or just field, and H1 is there is an association. Oh, that's my phone, sorry. Between apple quality and field. So basically the hoe goes with the no. That's what I say on my face, say no to the hoe. Excuse me for that. So then what we've got to do is, this is our contingency table test. So we need to set up the contingency table of the observed values. So we've got excellent, good, satisfactory, and we've got top field, middle and bottom, and then we need to have totals and totals here. Okay, so 36 at the top here, top field 36, 36, 21, middle was 18, 50, 31, and then it was 30, 42, 36. Right, so adding up the totals, you're going to get 84, 128. I'm going to do it in a different colour actually. So we know there's a, oh, that's good. Difference. 84, 128, 88, 93, 99, 108 and 300. Right, at this point then, I'm going to go to my calculator, because we need to work out the expected. Now the idea is you work out one expected value to show that you know what you're doing. So to get this top expected value, what we need to do is to say either we want 93 300ths of 84 or 84 300ths of 93. Either way, it's 93 times 84 over 300, and that will give us our first answer, 93 times 84 divided by 300, which is 26.04. Now it's good to do that, because now we're going to just go to our calculator. In the maths option, we're going to tick for matrix, and we're going to put 3 by 3 matrix and put in all the details. After that, we're then going to go to the stats option and go test chi two-way table, which is what this is. Press equals, and we get our chi-squared value. So this is my test stat, which is the chi-squared value, and I've got 11.5150. I've got a probability and a degrees of freedom, and the degrees of freedom would have been 3 minus 1 times 3 minus 1 for the rows and the columns, which is 2 times 2, which is 4, which comes up on the calculator, so you don't need to worry about that. And now I'm going to see if I can delete or make this smaller, which I can't with that there. Hold on. Move that over. Okay. Right, so then what we need to do is to draw out oh, there we go, it's there, wasn't it? Right, it's to draw out the next bit. So I'm going to leave that test at the bottom because officially we should have done the expected table, which they will expect, which you can get off now your matrices, the second one, matrix B. So if we set the table up in exactly the same way, top, middle, bottom. Don't need the totals this time. We know the totals are going to add up to whatever they add up to. So we had 26.04 here, and then there's 27.72, 30.24, 39.68, 42.24, 46.08, oops, 27.28, 29.04, 31.68. Okay, sorry I can't show you the calculator usage, I can't, but hopefully you follow the buttons that I was pressing. Fingers crossed anyway. Right, so there's my expected. What would really be good at this point is to be able to see what the actual, okay, so this is the next point. So what I would do then is you compare and contrast, but what can be a really good thing is to see what the contribution, so the chi-squared statistic that we're looking for, our test stat, is observed minus expected all squared over the expected and summed up, which means we're going to look at 36 minus 26.04 squared over 26.04. Then we're going to add, I'll go across 18 minus 27.72 all squared over 27.72 plus dot dot dot, and we know that equals this number that we got off our calculator, which is 11.515. What would be a really good thing to do, but takes time, is to work out what each of these values give you and to stick it in a similar table. And if you do that, because I've already done it, you end up with, if I put individual contributions, it just helps you identify where the big changes are, which can sometimes be difficult to see clearly. Now, if you're looking at the two tables here, you can see expected here was 26 and we got 36, expected was 27, we got 18, 39, 36, 27, 21, 29, 31, 30. I mean, they look reasonably similar. These two look to be the ones that are massively different. And to check that, you just literally work out what this calculation is and you put it in the first, in each bit. So I'm going to go, well, we've got top, middle, bottom. And if you do work out each little bit, these are the values you get. If you don't want to work it out and you're just going to, if you think there are a couple, then I would look at each one individually and find out which one kind of stands out, and then work out the contribution to see if it is large. Because the whole point is the chi-squared test is kind of like that. So the rejection region is always this side. So when we look up our critical value, whatever big numbers are helping us get past the critical value are the ones that are making us reject H0. So having gone to that stage, if we then look up our critical value at the 5% level with degrees of freedom 4, we end up with 9.488. So if that's there, our 11 is way past it, so there's definitely no significant evidence. There is significant evidence, massive significant evidence, that there is an association between the apples and the field. so it does affect how we're growing. On to the next one then. I'll make this slightly smaller and then I can expand it. So, Richard lives near a town. There's a mistletoe fair. Mistletoe can grow in apple trees. It's a parasite. It grows on the grows in trees as a parasite. He also read that the apples, but if you do have them, then they produce fewer apples. So Richard decides an experiment. He will use apple trees in one of his 3 fields as hosts for the mistletoe. Using the data we've previously collected, data from the CSAT, which of the fields should he use, and give a reason for your recommendation. Well, the most notable difference are those two we were talking about. So the top field has more. If we look back again, the top field, so this one, that was what was expected, and we saw it produced a lot more. And then the middle field was expecting, there we go, no, that's what, 27, and we got 18, so it produced less than expected. So those 2 fields are interesting, and given that a field with mistletoe will produce a lower yield, possibly, from what it says here, perhaps we should recommend the middle field as a lower yield of worse apples. Seems okay, that's fine. Or one of the other 2 fields, it doesn't really matter, crossing it. Which other one? Or you see the top field does produce the least amount of apples anyway. So anything that makes sense is okay, basically. These ones are producing the bigger, just satisfactory apples. So it's literally, if you can back up your comment, I probably would say the middle field because it produced the least expected, but of the worst apple. I don't know. So see how you feel. But the bottom field has the most unsatisfactory. I don't know. It's interesting, isn't it? But the least excellent might be the one to go for. Maybe that's it. What's the other bit? Reliability and conclusion of the test. This data that we've got is literally only from one day, I believe. That morning, exactly. So it's kind of really, he needs to do a bit more investigation. So we're saying, what do we say? Top field for mistletoe, and then do more investigations, get more data, basically, not just one day. And then, because with regards to the mistletoe, I wonder how much, it's like investigate which is more lucrative, apples or mistletoe. Find a balance. Not sure that's the right thing to say, but I think that's, any of those 3, because there's five marks there. And also maybe how severe is reduction of apples versus mistletoe. Basically, you need to make sure you've got at least five comments to make sure you get your 5 marks. Try more, or whatever you can think of that makes sense to you.